Okay, welcome back, class. Now we are working on 10.4, which is chords, inscribed angles, and polygons. We're going to continue on with circles. We're going to talk about these type of angles, okay, and then investigate the difference between the central angle and the inscribed angle. All right, so let's get right into it. First, let's start off with some definitions, okay? So we talked about a couple of these, and now we're going to talk more in depth, all right? Remember, this is a tangent line right over here, right? And so a tangent line is a line that just touches the circle as it passes by. Okay, so as this passes by, it just touches at one spot right over there. Okay, next is called a secant. Okay, the difference between a secant is it passes through. Okay, it passes through the circle. Okay, so if we see right over here, it's a line that cuts through the circle at 2 points. Okay, so it goes through right there and right there. Okay, so it passes through, and the tangent just touches at one time. All right, and then the difference between the secant, okay, and the tangent, okay, and now we're going to talk about a chord. Okay, so a chord, okay, the difference between that and a chord is its endpoints are on the circle. Okay, so it has endpoints that are on the circle, right? The secant goes through it, the chords stop right there. Okay, so that's the main difference. All right, so we're going to talk about those today: a secant, a chord, and a tangent. We said a diameter is a chord that goes through the center. All right, so it has to go through the center to be a diameter. And then we said a part of the circumference, like right here, that's called an arc. Okay, so we're going to use that today as well, that arc. All right, so let's get right into it. So first off, what is an inscribed angle? Okay, so that's a key word that we're going to talk about today, an inscribed angle. So these are examples of inscribed angles. Okay, so you see that these are not inscribed angles. All right, so what would you say the definition is? Okay, so an inscribed angle would be an angle whose vertex is on the circle. Okay, it's on the circle. So if we look at these right here, this vertex of this angle, right, is right there. It's on the circle. Okay, this vertex of this one, it's on the circle, right? The vertex of this one is on the circle. Okay, so this one has a chord, right? And this is a secant. These are two chords. These are chords. But the main thing is that on an inscribed angle, the vertex is on it. So these are not examples of not, right? This is not on the circle. So the vertex is not on the circle on both of these, right? So if we see that right there. So on these, the vertex is on the circle. Okay, so that's the main difference between an inscribed angle and a non-inscribed angle. All right, so now that we know that, let's get into some vocabulary. All right, so it says identify the highlighted part of circle O or P. All right, so this is circle O, that's circle P, this is a highlighted. Okay, well, what do we notice about that? We notice that this endpoints are on the circle. All right, so if the endpoints are on the circle, that's called a chord, right? Okay, so that's what that part is. All right, so let's look at this one right here. It says identify the highlighted part, all right, of a circle O or P. That's O. There's nothing highlighted. That's P. All right, well, what do we notice? We notice that that is an angle, right? We see that right there. That's an angle, and the vertex is on the circle. Vertex is on the circle. All right, so what would we call that? We would call that an inscribed angle, right? It's not a tangent. It's not the center of the circle. It's not a central angle, right? A central angle, what is a central angle? Well, the vertex would be on the center, right? Vertex would be on the center if it's a central angle. Inscribed angle, the vertex is on the circle itself, okay? All right, nice. Let's keep it going. Let's look at this one. It says, which of the lines or segment below is tangent to circle O, right? So remember, tangent means line that just touches the circle. All right, so it's a line that just touches that circle. Okay, so let's look over here. JB. JB goes through it, right? That goes through. So that one's a no. All right, what about JF? JF. JF goes through. It also goes through, right? So that's no good. What about GA? GA just touches, right? BC goes through. BC goes through as well, right? So BC goes through, and so our answer is GA, because that just touches, right? Let's go and highlight that. GA, right? That one just touches. All right, next. It says, which one is a secant? So we remember a secant goes through the circle. All right, so which one of these goes through the circle? Let's look. ZO. ZO is just a radius, right? That's a radius. Right? So that's wrong. What about DA? DA. DA doesn't go through it, right? DA is a tangent. Right? So that's no good. What about this one? LR. LR doesn't go through this the triangle, right? So that's no good. And then ZY. ZY, right? ZY passes through, right? It goes all the way through. So that one is a secant. All right, so that's the main difference between those. Go and do your practice on Delta Math. We said a tangent just touches, a secant goes through it. A chord has the endpoints that are on the circle, and an inscribed angle has the vertex of the angle on the circle itself. Okay, so this hint tells us a hint of an angle. All right, that's what that tells us. All right, so let's get right into some more practice. All right, so what we want to recognize is the difference between the inscribed angle and the central angle. So we talked about that last time on the central angle. Okay, the inscribed angle, the measure of an inscribed angle, okay, so the measure of this angle is 1/2 the measure of its intercepted arc. Okay, so if this is the angle right here, right? If that's the angle, okay, this right here is the intercepted arc. Okay, this right here, right? And so it's the measure of the angle is 1/2 that, right? So say for instance we said that this angle was 50 degrees, right? That means this arc has to be 100 degrees, right? Because we said the angle is 1/2 the measure of the arc. Okay, so that's what we want to keep in mind. So if the measure of the intercepted arc is twice the measure of the angle, then both of these are true. This says the measurement of the angle, ADB, is the measurement of arc AB divided by 2, right? 1/2 of this is 50. Or think this way. If we go backwards, then we say the measurement of the arc is 2 times the measurement of the angle. So 100 is equal to 2 times 50. And that makes sense, all right? So that's what we need to keep in mind. The intercepted arc, the angle is 1/2 of the arc, all right? So then if we remember from last time, we said the measure of the central angle is equal to the measure of its arc, right? So this is from last time. So if we see right over here, let's take a look over here, all right? So if we see this over here, that right there tells us that this is a central angle. So angle DOE, right? DOE is a central angle, right? So if they're equal, if this is 90 degrees, then this much of this arc should be how much? That should be 90 degrees as well. And think about it. If all the way around is 360 degrees, right? And that's a quarter of it, right? Or a fourth of it, that means that's 90, that should be 90, that's 90, and that's 90, right? So this is a central angle because the vertex is at the center. Right? So that's the vertex is at the center. All right, now on this one, the vertex is on the circle, right? So it's on the circle. So we said it has to be half of the arc, right? So if the arc is 90, it makes sense that that one's 45, right? If this is on the center, that means it's the same. So if that's 90, that's 90. If that's 90, that's 45. All right? So hopefully that makes sense so far. If not, let's get right into some practice. All right. So here's what we want to talk about. We're going to see the difference between these are the central angles or inscribed. If it's central, the measure of the central angle is equal to the measure of the arc. If it's inscribed, the measure of the inscribed angle, okay, is half the measure of the arc, which means take the arc, divide by 2, right? All right. So let's get right into some this example. Okay. It says encircle D. Right, so that's the circle D with the measurement of angle CFE equals 30. All right, so that says CFE. Okay, so that angle is 30 degrees, right? So let's put it 30 degrees right there. Okay, find the measure of minor arc CE. So that means this way would be a major arc, right? So minor arc tells us less than 90, less than 180 degrees, right? So that means this right here. Okay, so we said the measurement of the angle is equal to the measurement of the arc divided by 2, right? Or the measurement of the arc is equal to 2 times the measurement of the angle, right? So let's check it out. If they want us to find CE, they want us to find the arc, right? So let's use this one right here. Okay, so we're going to say the measurement of arc CE is equal to 2 times the measurement of CFE, right? So that means that it's equal to 2 times 30 degrees, right? Which means it's equal to 60 degrees. That's our answer. All right, so arc EC is equal to 60 degrees, right? Because the angle that created it was 30 and it was on there. So that means this is twice as much. All right, let's get right into another one. It says encircle R with the measure of the minor arc QS equals 36 degrees. So QS is 36 degrees. Find QTS. So they want us to find QTS. Well, what do we notice? We notice that the vertex is on the circle, right? That's what we noticed about this one, right? That's the vertex is on the circle. Okay, so if it's on the circle, that means the angle, right? So the measurement of angle QTS is equal to the measurement of arc QS divided by 2, right? So that means it's equal to 36 divided by 2. If we put that in our calculator, that's equal to 18 degrees. All right, so that's just the main thing. We just have to recognize that relationship. Okay, all right, let's get right into our last 2 examples right over here. Okay, so now we're stepping up a little bit. It's just a little bit because we're still doing the same math, but we're dealing with algebra. But we got this, all right? So let's check this out. It says the measurement of angle ROP is 51. So let's trace that out. ROP. Okay, so that one is 51 degrees for that angle. Okay, solve for X. if the measurement of arc AP, right? This says measurement of arc RP, right? That's what that means. The measurement of arc RP is 5x minus 33. So RP is right over here, right? RP is right over here. We can say that that is represented by 5x minus 33. All right, so now let's just set it up, right? We said the measurement of the angle is equal to the measurement of the arc divided by 2, right? So let's just fill that in. Okay, so we know that the measurement of the angle is 51 degrees, right? So 51 degrees is equal to, we're trying to find the measurement of the arc, right? So we're going to put that right there. 5x minus 30. We're trying to find x, right? So we know the measurement of the arc is 5x minus 33 divided by 2, right? So the first step is to set it up. Second step is to solve by cross multiplying. All right, so if possible, we're going to cross multiply. So let's go ahead and do that. So first thing we did is we set it up, right? Second step is we're going to do that. So now let's cross multiply, right? So if we cross multiply, we're just going to put that over 1, right? And then I'm going to think, okay, this times this, so that'll give me 5x minus 33 equals 2 times 51, which is equal to 102. All right, so now we're just going to do our basic math, right? Once we set it up like that, we're just going to solve. So we're going to 5x equals 135, right? Divide by 5, divided by 5. That means x is going to be equal to 27, right? And so since they're asking for x, then we're done. All right, so let's go and highlight that so we recognize that. All right, let's get our last problem right over here. See if you can set this one up on your own. All right, so it says the measurement of arc xy is 130. So, I'm sorry, z, right, to x. Okay, so from z to x is 130 degrees. It says solve for x if the measurement of angle ZWX is that. So let's trace that out, right? We said that ZWX, so ZWX. It's a little weird because they're normally a number, but we know that that's 9x plus 31, right? So if that's 9x plus 31, the vertex is on the center, right? So we know we're going to set it up, and we're going to say the measurement of the angle is equal to the measurement of the arc divided by 2, right? So the measurement of the angle, all right, so that's step number 1. Step number 2, we're just going to set it up. So we're going to say that 9x plus 31, right, which is the measurement of our angle, is equal to the arc divided by 2, is equal to 130 degrees divided by 2, right? Because that was what we used as far as our information. Okay, so now let's cross multiply. All right, so if we cross multiply, we're just going to put that over 1, right? We're going to say 1 times 130. So I like to put the numbers on the right side, right? And then 2 times that. So you could either do that in your head or just take 2 steps. So we'll just take 2 steps. So the first step is writing it just like that, right? 2 times 9x plus 31 equals 130 times 1, right? So now let's just do that cross multiplication. So it's going to be 2 times each of those. So 2 times 9x gives us 18x, right? 2 times 31 gives us positive 62 equals 130. Okay, so now we have that positive 62, so we know we need to subtract 62 from both sides, right? I'm going to change the color over here. Subtract 62 over there. Subtract 62 from the right side, right? So we're going to cancel that out. We're going to bring down the 18x equals that 130 minus 62 gives us 68, right? And so we know what the last step is. We're going to divide by 18, divide by 18, right? So if we put that into our calculator, x is going to be approximately 3.777, right? And so it tells us to round to the nearest tenth, right? Tenth means 1 digit. So what we're going to do is we're going to think about that 7, right? We're going to ask the 7 next door, what do we do with it? We're going to raise it or keep it, right? That tells us to raise that to an 8, right? And then let's move to the left. So x is still going to be approximately, but it's going to be that 3.8. All right, so that's our stuff for today. I know you have this. If you have any questions, just let me know.